But in SiS3 whole 3N, that is tricylylamine, nitrogen atom does not possess the lone pair, rather it forms delocalized p-pi d-pi bonding with vacant d orbital of silicon atom, as shown in the following figure. Here you see that nitrogen is in the sp2 state. Dotted lines represent as usual p-pi d-pi delocalized bond. All the three silicon atoms and nitrogen atom are in the same plane. But this is not possible in trimethylamine CH3 whole 3N. But this is not possible in trimethylamine, that is CH3 whole 3N, as carbon atoms do not have vacant orbitals. Question number 7. CO2 is linear, but SO2 is bent. Why? The answer is, it is clear from the hybridization of central atom. Look into their structures. In carbon dioxide, carbon is sp hybridized, while in SO2, sulfur carries a lone pair, therefore it is sp2 hybridized, and hence the molecule is a bent molecule. Question number 8. Why the nitrogen atom in CH3CONH2 or in general RCONH2, known as alkanamide, is said to be in sp2 hybridized state? The answer is, at first glance, the structure of ethanamide CH3CONH2 would be as drawn here: CH3 C double bond O, single bond nitrogen, it carries a lone pair and attached with two hydrogen atoms. Therefore, nitrogen atom must be in sp3 hybridized state, but RCONH2 exhibit following properties. First one is, there is no free rotation possible about carbon single bond nitrogen. Second, carbon nitrogen bond length is 1.32 angstrom, while the standard CN single bond length is 1.47 angstrom. So there is a decrease in the bond length. These observations can be explained if there is double bond between carbon and nitrogen in CONH2 group. In fact, RCONH2 is a resonance hybrid of following two structures, as given below. Then question number 9. In carbonate ion, all the carbon-oxygen bond lengths are same or different? Explain. The answer is, these are same, each of 1.29 angstrom. In fact, standard carbon-oxygen single bond length is 1.43 angstrom, and carbon double bond oxygen is 1.22 angstrom. This suggests that carbonate ion must be a resonance hybrid of the following structures. The three structures are given here. Now we shall deal with some objective questions. So here is question number 10. The question is, Which of the following is correct with respect to carbon single bond oxygen bond length? The options are COF2 more than CH3 COCH3, B. COF2 less than CH3 COCH3, C. COF2 equal to CH3 COCH3, and the option D. COF2 does not exist, hence comparison cannot be done. The answer of the question is that the correct answer is A, because in COF2 we may call it carbonyl fluoride. Its structure is given where carbon is in the sp2 hybridization state. We find that partial double bond character in both the carbon-fluorine bonds due to delocalized overlapping between a filled p orbital of fluorine and vacant p orbital of carbon is possible. That weakens the carbon-oxygen bond and hence its length increases. This is also known as synergy effect. But this is not possible in CH3CO, known as acetone. Question number 11. Which is are true about fluorine nitrate FNO3? The options are A. Oxidation state of nitrogen in it is +5. B. It contains FN bond. C. It contains OO bond. It contains a peroxide group. The correct answer is A only, because its structure is as given over here. The nitrogen atom is in sp2 state. Question number 12. The question is, which is a stronger Lewis base? Ammonia, NH3, or phosphine, PS3? And why? The answer is, in ammonia, nitrogen atom is sp3 hybridized and the lone pair is present in a sp3 hybrid orbital, as is clear from the following configuration. The 4 sp3 hybrid orbitals are formed, which are directed towards the 4 corners of a tetrahedron, but one of the sp3 hybrid orbital carries a lone pair with it. So, the structure of ammonia, rather the shape of ammonia molecule, is pyramidal due to the presence of a lone pair. The bond angle is 107 degrees. It is less than 109.5 degree due to the presence of lone pair. On the other hand, the bond angle in PS3 is about 93.5 degree, which suggests that phosphorus atom is not hybridized here. Hence, lone pair on P in PS3 is present in pure s orbital, which is compact due to its spherical nature. Hence, PS3 cannot donate its lone pair so easily as NH3 can do through its sp3 hybrid orbital, which is directed. This is sometimes known as Drago's rule. according to which if central atom is in third period or below in the periodic table and electronegativity of atoms attached to that is equal to or less than 2.5, then the lone pair will remain inactive in s orbital. Well, question number 13. The observed nitrogen-fluorine bond length in NF3 is found to be more than expected single bond length. Why this is so? The answer is, this is due to repulsion between lone pair on the nitrogen and lone pairs on fluorine atoms, as shown in its structure.